at binomial distributions, and specifically we are looking at the mean or the expected value. So on the formula sheet, I've actually just taken a screenshot of the formula sheet. So this is what we've got going on. It looks really complicated, but it's not so bad. Okay, so what we're looking at today is this one here. And this is another way of talking about the mean or the expected value. This symbol here is for the standard deviation squared or the variance. Okay, so if they ask for the standard deviation, you would just square root this. If they ask for the variance, you would leave it as is. So when we talk about the mean or the expected value, it's fairly intuitive, and you probably would have done it before without even realizing you were doing the expected value of a binomial distribution. But like the classic example, if I'm rolling a dice and I roll it 60 times, and I want to know how many 4s I would expect, well, then I'd go, well, the chance of me getting a 4 is 1/6, and I'm rolling it 60 times. So I'm expecting to get 10 4s. And that's exactly what we're doing. And that is why the formula is N times P. Okay, the variance is obviously more difficult to understand, but just reminding you what the variance and standard deviation mean. So standard deviation is the average deviation from the expected value. So on average, how much does the data vary away from the mean? Variance has no real meaning other than that is the standard deviation squared. Okay, so standard average deviation is how much it's deviating from the mean. So it's the average of how far it deviates from the mean. So we're going to look at how we use those formulas with these couple of examples. So the first one, dead easy. You are simply working out the mean and variance. So remember that when they give it to you like this, it's NP. It's given in the order that it's given on the formula sheet. So we can just say that the mean is equal to 4 times 0.4. So we know that it's 1.6. When we do the sigma squared or the variance, just notice that it goes NP 1 minus P. So you can literally take this answer and chuck it there. So it's 1.6 times 1 minus 0.4. So 1.6 times 0.6. Oops, 0.6 is 24, so 0.96. And then if it asked for the standard deviation, we would just square root that answer. Square root answer equals 0.979. I didn't see the rest of it. Okay, the next question, just like a typical Cambridge one, if we know the mean is 18, we're saying NP equals 18, and the variance, NP 1 minus P, is equal to 12. So it's simultaneous equations, but it's not exactly nice. The really important thing I want you to notice again is that NP equals 18, so this aspect equals 18, and that enables us to instantly get rid of one of the variables. So just 1 minus 12 over 18, you're going to find out that P is, what's that, 6 out of 18. And then you can just chuck that in here. So N times 6 over 18 equals 18. And so N is equal to 18 divided by 6 over 18. So N is equal to 54. And that is how we work it out. So again, you can have a go at the questions below. Pause the video if you'd like to practice them, and then the answers are over here. Whoops. Like and subscribe if you want more of this content.